Hi again, senior high students. It's still me, Miss Leia. And in this video, we'll talk about uniformly accelerated motion. But this time, we're now in the learning targets 2 and 3. So I want you to be able to identify the variables given in a UAM problem. And I'd also like you to be able to determine the appropriate sign conventions in the identified variables. Okay, so there are only 5 variables to remember in solving kinematics problems for UAM. First is initial velocity, final velocity, then we have displacement, we have acceleration, and then time. Of course, you have to remember those symbols because you have to write your solutions in shorthand notation for simplicity. But the next concern is, how do we identify those variables in a given problem? Okay, it's pretty simple, although it can be tricky sometimes. Let's say, for example, there's a physics problem, and the physics problem discusses about a car which starts at point A, at rest, at 0 meters per second, and naturally you would describe this as the initial velocity, logically speaking, right? And then let's say, for example, the problem tells you that at point B, the velocity becomes 27 meters per second. Naturally, you would think that this would be, or this should be, the final velocity in this case, okay? But it's not always correct because it depends on the question in the problem. Suppose that point A to point B happens within a span of 10 seconds, for example. Okay, so from point A to point B, it took the car 10 seconds, as an example. What if the question is, what is the car's displacement after 5 seconds? So let's say, for example, this is where 5 seconds is. And the problem wants you to solve for the displacement after 5 seconds. Are you supposed to use 27 meters per second as the final velocity for you to solve for displacement after 5 seconds? I'll repeat the question. Are you supposed to use the final velocity here, which is 27 meters per second, for you to solve for the displacement after 5 seconds? Yes or no? The answer is no. Okay? You are not supposed to use 27 meters per second as your final velocity if you're solving for the displacement here, simply because this 27 meters per second velocity, it happened after 10 seconds, okay? Now, if the problem wants you to solve for the displacement after the 5-second interval, this is not applicable. This velocity is not applicable. It talks about the velocity after 10 seconds, while the problem wants you to solve for the displacement after 5 seconds. So, Miss Leia, how do we deal with that? Okay. So, in such case, again, this is not the right final velocity given what the problem asks you to solve for. If the problem wants you to determine the displacement after 5 seconds, it's okay that this is still the initial velocity, right? It still starts from rest from this point. But if this is, given that this is 0 second, right? Okay. But if you want the displacement after 5 seconds, the final velocity to use should be the one given after 5 seconds, okay? If it's not given in the problem, then there should be some other given. Let's say, for example, the acceleration can be given. That's another thing that they can give you so that you will have sufficient variables to solve for it. So the thing is, the variable should have to be in unison, meaning to say, if this is your initial, let's say, for example, this is your initial velocity, and the final velocity is the one at point B. Whatever you solve for using these values, 0 and 27 meters per second, they're concerned with what happens between A and B, right? Okay, so if you solve for the displacement and this is the velocity you use, you're solving for the displacement from A to B, right? Okay, but once again, if you are solving for the displacement after 5 seconds, you're not supposed to use a velocity that happened after 10 seconds. It's as simple as that, okay? Going forward, okay, I have a misconception to correct because some students would tell me, initial velocity is always 0 because Miss Leia, naturally the car or any other object would start from rest, but that is wrong, okay? The initial velocity may not always be 0 in a given physics problem, okay? Why? Simply because some physics problem would start talking about the events that happen in the middle of the car's journey. For example, a physics problem might say, a car is moving at 16 meters per second. And at some later time, it reached 25 meters per second. It can be something like that. So meaning to say, a physics problem may not care about the resting part, the earlier parts of the car's journey or any object's journey. They might talk about the things that happen in the middle of the object's journey. And in a case like this, because you only have two velocities to set, obviously, this would be your initial velocity. Okay, this would be your initial velocity. And then, this one would be your final velocity. So you see, initial velocity is not necessarily always zero, okay? It depends on what the problem wants to talk about, because a problem, again, may not care about the resting part of the object. Going forward, okay, don't forget about the units, okay? Meters per second for the two velocities, meters for displacement, because displacement is the shift in position, and then acceleration is meters per second squared, and then time is in seconds. I've explained in another video why acceleration is in meters per second squared. And then for the sign conventions, okay, if the object, or if the displacement is measured on the right side of what you consider as the starting point, it should be positive. If the displacement is measured on the left side of what you consider as the starting point, it should be negative. And for the velocity, if the object is going to the right, it should be positive. And if the velocity is going to the left, it should be negative. Okay? I won't talk about acceleration for now because it will prolong the discussion, okay? When it's needed, I will talk about acceleration because it might be complex also because it requires a recall of the second law of motion. So I'll skip that for now. But what I like us to do is to try identifying the variables in this given physics problem, okay? So let's try to work this out. Just the variables. We're not yet going to solve it entirely. So it says here, a cyclist accelerates from rest at a rate of 2 meters per second squared and reaches his top speed after covering a 100-meter distance. How much time did it take for the cyclist to cover the said distance? So what are those variables again? So of course we have initial velocity. Okay. We also have final velocity. We also have displacement, acceleration, and time, okay, right? So let's see what we have in the problem. Let's read it carefully. A cyclist accelerates from rest. Okay, now look at this one. It might look as if we don't have so much given because you don't see a lot of numbers. But it's possible for a given to be implicitly stated, or it can be just implied. So let's say, for example, this problem seemed to not mention about initial velocity, but when something starts from rest, it would mean to say that the initial velocity is 0 meters per second, right? Because starting from rest would mean your velocity is 0 initially, okay? So the initial velocity in this problem is 0 meters per second. Okay, now it says it accelerates at a rate of 2 meters per second squared. So it's very explicit, it's directly stated the acceleration is 2 meters per second squared. Going forward, he reaches his top speed that we don't know after covering a 100-meter distance. So for now, well, we would assume straight line motion because we're talking about one-dimensional kinematics. So this distance, which is 100 meter, we can assume that that is the displacement in the problem, okay? And the next, how much time did it take for the cyclist to cover the said distance? So no more given, okay? The only given variables that we have are initial velocity, displacement, and then acceleration, okay? And what about velocity and time? What are they if they are not the given variables? We'll learn that in the next video.